Today we are going to see a case study on boundary value problems in civil engineering. When there is a vertical column attached to a horizontal beam, when a load is applied on the horizontal beam, the bending occurs in the beam. So the civil engineers want to find the bending of the beam, so they use mathematics.
So here if you see, there is a vertical pillar. You can see in the structural engineering, the engineers, the civil engineers want to know, so what strength to be given to the pillars so that withstand the quantity of load applied, the quantity of load applied. So that is what they are trying to say here. So we can use mathematical techniques. We can use mathematical techniques in order to understand how the bending will happen, how to calculate what kind of measure. So what measure, what is the bending level, bending measure that can be understood in this particular horizontal beam when a load is applied. Okay, you can see where are the structural engineering happens, maybe flyovers. You can see the flyovers, right? So there are 4-story building, 10-story building. So each, it depends. It can be an industry, it can be a mall, it can be a home. So they will calculate how much load it will withstand, how much load it has to withstand. Then the beam has to withstand. Accordingly, the strength of the beam will be created or structured. So in order to know what strength we should have, so what strength to be given to the beams so that it withstand that strength. It can be a cantilever beam. It can be a cantilever beam. What do you mean by cantilever beam? So it is kind of one side it is connected, other side is free. It can be a portico overhead beam also, where there is no beam to hold this. That way it is connected in one side and one side is not connected. You have seen in various places. You have seen in various places. So in order to calculate the strength, what should be given to the beams, we can use mathematical ideas. So those things can be taken as boundary value problems because it has its own some boundary conditions. It has some its own boundary conditions. So using those conditions and mathematical ideas, you will try to identify what strength it should be given, and we can identify is it holding that strength to the load level given. Then even we can understand how much bending can happen if a particular amount of load is given. In all these areas, we can use the concept of mathematical modeling. That is, we can solve the boundary value problems. Not only this is a straight structure thing, it can be a different curvical beams also. It is not that the civil engineers always makes vertical and horizontal beams. It can be a curvical beam also. Even that we have to try analyzing and we can apply the mathematical ideas. It's a very, very important thing when it comes in structural engineering. So the civil engineer will calculate how many beams to be given, how many columns to be given, what is the strength to be given. You know, inside the beam, what is there? What is there inside the beam? We have rods, iron rods. We have various iron rods inside. So the thickness of the iron rod, maybe 16 mm rod or 18 or 12 mm or 10 mm, what strength it has to be given. Again, as engineer, you have to work out. You will be working out. So what strength that rod should have, what kind of thickness rod should be given. You have seen in various constructions. It is not that always 16 mm rods are used. Even they use 10 mm rods. Even they use 8 mm rods. So it depends what is the load it is carrying. It depends. So how you are going to calculate it? So you should know the strength, actually what strength it should withhold. What strength it should have. So in that area comes the concept of mathematical modeling. So we as engineers, we have to understand the right plan, right mathematical tool, what should be implemented in these kind of areas. You can have a deep calculation over it, and you have to understand before construction. See, after construction, you cannot check, it is a waste of money. You have to understand what strength in the beginning itself. So, beginning of the construction, before starting the construction, you have to calculate what is the load, what is the amount of quantity of iron required. So what that mixture, even that concrete mixture, he has to calculate. Am I right? In these many areas, we can use the idea of mathematical tools. Okay, in these areas we can use the concept of mathematical tools, because it is very very important, because constructions are very very important, no? Because it cannot just like that we cannot construct. Am I right? So this is the very very important. So as they brought this concept of case study, I was trying to connect with mathematics. So I'm happy that they have given the boundary value problems in beam structures. Am I right? These are beam structures where mathematical ideas are used. Thank you.